Okay, so today we're working on implicit differentiation. And the key to implicit differentiation is using the chain rule. So this is an application of using the chain rule. Just put here chain rule. Okay, so pause, copy down the problems, and then we're ready to go. Okay, so here's our first problem here. Now, in order to do this problem, which is I'm trying to find dy dx, right? So my goal is to find dy dx. Which is, remember, that's the same thing as saying my goal is to find y prime of x. Okay. So I start off by taking the derivative with respect to x of both sides. So if I know that x squared plus y squared is equal to 25, and by the way, what is this a graph of? What does this curve describe? This curve is a circle centered at the origin with radius 5. Okay, that's not a good circle. So it is a circle. There we go. Centered at the origin with radius 5. So essentially what we'll be doing is finding a formula or a function that gives us the slope to the curve at any point. So that's what we're essentially doing. Notice, by the way, that the slope is going to be undefined at this point, right? Also, the slope of the tangent line is undefined at this point. So right here and right here, we've got 2 points where the slope of the tangent line is going to be undefined. So we'll see how that plays out in our formula for the derivative. Okay, so back to here. So I'm starting out with x squared plus y squared equals 25. My next step is to take the derivative with respect to x of the left-hand side and say that's equal to the derivative with respect to y of the right-hand side. It's x squared plus y squared. What is the derivative with respect to x of 25? This is just going to be 0. And here, I'm going to be able to rewrite this as the derivative with respect to x of x squared plus the derivative with respect to x of y squared. Okay, so now we've got our new equation here, which is that the derivative with respect to x of x squared plus the derivative with respect to x of y squared is equal to 0. What is the derivative with respect to x of x squared? That's just going to be the power rule, which will give us 2x. Now here, we will need to use the chain rule. So I'm going to go over here to the left, and my goal is to find d dx of y squared. This is it's like my goal within the larger problem. So I'm going to say, what is my outer? What is my inner? My outer function is just x squared. My inner function is y. So this is my f of x is going to be x squared. My g of x is going to be y. So what is f prime of x? It'll be 2x. What is g prime of x? It'll be y prime. So my formula, which says that this derivative is f prime of g of x times g prime of x. My f prime of x is 2x, so I'll have 2 times g of x times the derivative of g prime, which is just y prime. But what is g of x? G of x is equal to y, so we'll just have 2y prime. So over here, This derivative is going to be 2y prime. So now we've got our equation saying 2x plus 2y prime equals 0. So if I want to solve for y prime, divide both sides by 2, divide by 2, divide by 2, right? The 2's are going to cancel out. So I'll have x plus y prime equals 0. Y prime equals negative x over y. So notice that this is undefined when y equals 0. And back to our picture, these points right here, this is 5, 0. The coordinate of this point is negative 5, 0. So y is equal to 0 means that slope is going to be undefined, okay? Because can't divide by 0, okay? And then same thing over here. Since y is equal to 0 at this point, the slope of the tangent line is undefined, okay? So what is our final answer? Let's put our final answer is y prime equals negative x over y, and we'll put a little box around it. Okay. So this is the first one. Let's go to the second one. 4 cosine x sine y equals 1. Okay, we've got the same approach, which is going to be to take the derivative with respect to x of both sides. So the derivative with respect to x of 4 cosine x sine y is equal to the derivative with respect to x of 1. The derivative of 1 is just going to be 0. And now here, I'm going to need to use the product rule. And what do I get? I'm going to get the derivative with respect to x of 4 cosine x times sine y plus 4 cosine x times the derivative with respect to x of sine y, right? Because remember, if you have fg prime, it's f prime g plus fg prime. So here I'm using, this is my f, and this is my g, right? So I need, right, the derivative of f times g plus the derivative of g times f. Okay. So now what my equation is I've got this equation here, d dx of 4 cosine x times sine y plus 4 cosine x times d dx sine y is all equal to 0. Okay. Now, some of these are going to be easy or easier. What is the derivative with respect to x of 4 cosine x? That would be 4. Now, what's the derivative of cosine x? Negative sine x. Okay. The sine y just comes down, stays the same, sine y. The 4 cosine x stays the same, 4 cosine x. But now, what is the derivative with respect to x of sine y? We have to use the chain rule. Okay, so I'm actually going to scooch down here, and I want to compute d dx of sine y. So my outer is sine x. My inner is y. So sine x is going to be f of x. Y is going to be g of x. F prime of x is going to be cosine x. G prime of x is going to be y prime. Okay. So this derivative of sine y is going to be f prime of g of x times g prime of x. F prime of g of x is going to be cosine of g of x times, and then g prime is going to be y prime. Now, cosine of g of x, what is g of x? G of x is y, so we'll have cosine of y times y prime. So this derivative up here is going to be cosine of y times y prime. Okay. So now let's putting it all together. We're going to multiply these two together, so we'll have negative 4 sine x sine y plus 4 cosine x cosine y times y prime is equal to 0. Let me erase. Let me actually, okay, so now if you want to, so I'm stopping, in fact I can make this big so you can see how, right, so you can see now how we found that derivative. Okay, so now I'm going to erase it because that was just a little sidebar. Erase it now. And I need to solve for y prime because my goal is to find y prime. So I'm going to add 4 sine x sine y to both sides. So I get 4 cosine x cosine y, y prime, right, times y prime is equal to 4 sine x sine y. And now I'm just going to divide by 4 cosine x cosine y. Divide both sides by 4 cosine x cosine y. And on the left hand side I have y prime. On the right hand side the 4's cancel out. But I've got sine over cosine, which is tangent of x. And sine of y over cosine of y, which is tangent of y. So that is my final answer. Okay. So now, let's do the third one. I actually want to point out for the second one, you could have, because this is what we started off with, this was our original question up here, right? Our original curve. Sorry. For our original curve, we could have rewritten it as sine y equals 1 over 4 cosine x. And then, right, said y equals sine inverse of 1 over 4 cosine x, which is equal to sine inverse of secant x over 4. But when you do that, you're actually losing part of the information, right? So this curve right here is periodic, whereas if you write y like this, you're only looking at part of the original curve, okay? So this has a restricted domain because you're taking the sine inverse. So one of the reasons why you want to use implicit differentiation is because it saves you the trouble of needing to figure out how figure out how to take the explicitly defined derivative on each subdomain. We've got the same thing over here. Look at this this original problem right here. If we wanted to come up with a derivative formula, we would need to solve kind of like 2. Y equals square root of 25 minus x squared. And then we would also need to do y equals negative square root 25 minus x squared, right? And so we would have to do the derivative twice and then try to combine, right? So we'd get a derivative for that one. We get a derivative for the second one. And then we would have to try to combine them to get it back into one equation. So it's a lot simpler to use implicit differentiation. This third example shows one where it's not easy to solve for y, right? So even if you try to say, oh, I just feel more comfortable solving for y, you're not going to be able to do it. I'm not going to be able to do it, okay? So let's jump into it. So here we want to take the derivative with respect to x of both sides. So we'll have the derivative with respect to x of x e to the y is equal to the derivative with respect to x of x minus y. Now, of course, we can rewrite this as the derivative with respect to x of x minus the derivative with respect to x of y. Now, let's see here. What is the derivative of x with respect to x? That's just going to be 1, right? What is the derivative of x of y? That's just going to be y prime. Here, to find the derivative of x e to the y, we're going to need to use the product rule. Because we have this function times this function. Okay? So let's do a little computation over here. We need the derivative with respect to x of x e to the y is going to equal the derivative of x and then leave e to the y alone plus leave x alone times the derivative of e to the y. Okay? So it's the derivative of the first times the second plus the derivative of the second times the first. That's our product rule. What is the derivative of x? That's just going to be 1. So we have 1 times e to the y plus x. Now, in order to find, here we go, in order to find this derivative, we need to use the chain rule. Okay, so let me slide over here. And if I want the derivative with respect to x of e to the y, I'm going to say, what is my outer? My outer is just e to the x. What is my inner? Y. So my outer is e to the x, which is f of x. And my inner is y, which is going to be g of x. So g prime of x is just going to be y prime. F prime of x is just going to be e to the x. So my derivative, e to the y, is going to be f prime of g of x times g prime of x. And the f prime of g of x is going to be e to the g of x times, what is g prime of x? Y prime. What is g of x? Y. So we'll have e to the y times y prime. And so this we will put, undo, paste. We'll paste it here. Let's see if I just want to get rid of that. Okay, good, good, good. So now we're back over here. I'm ready to finish our product rule. So we'll have 1 times e to the y. This is too difficult to write. So we'll have 1. So we've got our 1 times e to the y plus x times e to the y, y prime. So we'll just have e to the y plus x e to the y, y prime. And so now this copy we placed over here. Okay, so we've got kind of like all these little bubbles or sub bubbles, right? So we needed this to find that, but then we needed to do this to figure out that, right? But back to our original equation, which is going to be this, the left-hand side, equals 1 minus y prime. So let's get back to it. So we'll have e to the y plus x e to the y, y prime, equals 1 minus y prime. Now our goal is to solve for y prime. So I need to put all of my y primes on one side. So I'm going to subtract 1 from both sides. And I guess I need to subtract x e to the y, y prime. Subtract x e to the y, y prime. Okay. So now that's going to cancel out. That's going to cancel out. So we have e to the y minus 1 equals negative x e to the y, y prime, minus y prime. And I'm going to factor out y prime. You know what? This is just too small and too rushed. So let's just go back to another. Copy, insert another page. Paste. So ridiculous. Okay. So now, let's see here. So I need to solve for y prime. Here's what I would like to do instead. I'm going to add plus y prime plus y prime. So I'll have e to the y plus y prime plus x e to the y, y prime equals 1. And now I'm going to subtract e to the y from both sides because I'm trying to solve for y prime. So that's going to cancel out. So I'll have y prime plus x e to the y, y prime equals 1 minus e to the y. Factor out of y prime. So I've got 1 plus x e to the y equals 1 minus e to the y. Divide both sides by 1 plus x e to the y, 1 plus x e to the y. So that's going to cancel out. And I've got y prime equals 1 minus e to the y over 1 plus x e to the y. Okay. And so here, see if I were to plug in e to the y, for this problem here, it is difficult to, I can't really plug back in or solve for x because the e to the y is just involved with, y is involved with x in a way so that it's difficult to write this as y prime in terms exclusively of x. So this is my function. This is my solution. Okay. So let's go to the next problem. E to the y cosine x equals 1 plus sine xy. And by now we should know what to do. We want to take the derivative with respect to x of the left-hand side, and that's going to be equal to the derivative with respect to x of the right-hand side. Okay. So over here we'll have e to the y cosine x, and over here we'll have 1 plus sine xy. Okay. So now, to find the derivative, this derivative, we're going to use the product rule. Okay, so let's just kind of scooch on down over here. We'll leave space. So if we want d dx of e to the y cosine x, it's going to be, I'm going to switch to prime notation, e to the y cosine x prime, right? Which is going to be the same thing as e to the y prime cosine x plus e to the y cosine x prime. Okay, now let's see here. E to the y prime, in order to figure this out, the e to the y prime, we're going to need to use the chain rule. Okay, the cosine x just stays the same. So we can put here, that's just going to be cosine x. E to the y, that stays the same. So we'll just have e to the y. And then cosine x prime, we know the derivative of that is going to be negative sine x. Okay. So now let's scooch over here to do the chain rule to find d dx of e to the y. Okay. So this is to find e to the y prime. Okay. So our inner is, or wait, I like to start with the outer. Our outer, e to the x, inner, y. So f of x is our outer, g of x is our inner, f prime of x, e to the x, g prime of x, y prime. So e to the y prime is f prime of g of x times g prime of x. So we have f prime of g of x. What is f prime? F prime of x is equal to e to the x. So we'll have here e to the g of x, and then g prime of x, that's just y, times, y prime. And now what is g of x? G of x is y. So this is going to equal e to the y times y prime. So up here, e to the y times y prime. So we can put all of this together, and our derivative is equal to, actually, let me blow this up. And so if you need to screenshot it, I'm pausing for you to screenshot it because I'm now going to erase. Okay. So now, let's see here, we're back to this derivative is equal to, so we've got this times this plus this times this. So we'll have e to the y cosine x y prime minus e to the y sine x. Notice that even though I could factor out e to the y, I'm not going to, because I'm ultimately going to be trying to solve for y prime. So up here, I'm going to copy and paste it here. This is our derivative for the left-hand side. Now let's find the derivative for the right-hand side. Okay, so for the right-hand side, the derivative of 1 is just going to be 0. And to find the derivative of sine xy, we're going to need, you guessed it, chain rule. Okay, so to find, I guess let me separate the page here. So to find dx of sine of xy, my outer function is going to be sine x. My inner function is going to be xy. So my outer function, which is f of x, my inner function is g of x. Okay. Now, I need f prime of x, but that's easy because I don't have to do implicit differentiation. In order to get the f prime of x, I'm just going to get cosine of x. So f prime of x is equal to cosine of x. And now to find g prime of x, that's the same thing as xy prime. I need to use the product rule. Okay, so let's go over here and we're going to say that g prime of x is going to be equal to the derivative of x times y plus x times the derivative of y. Okay? Now, what is the derivative of x? That's just one. And then y is going to stay. Right? We're not doing anything to y. And now x is going to stay the same. We're not doing anything to x. And what is the derivative of y? Well, it's just going to be y prime. Okay? So, our g prime of x is just going to equal 1 times y plus x times y prime. So just get y plus x y prime. Okay? So now, remember where all of this is going, right? So, let's see here. So, putting it all together, so we have the derivative with respect to x of sine xy is going to be f prime of g of x times g prime of x. Okay. Now, f prime of g of x is going to be, what is f prime? F prime is cosine, so we'll have cosine of g of x. And now, g prime of x, what is that? Well, we found that here to be y plus xy prime. This is y plus xy prime. Okay? So when we multiply these together, instead of cosine of g of x, remember, g of x is equal to x times y. So we'll have cosine of xy times y plus xy prime. So we could distribute this. You get y cosine xy plus x cosine xy times y prime. And the reason why I'm distributing it is because in my mind, I'm preparing for the fact that I need to solve for y prime. So I want y prime to be alone, essentially. So now, if we can, so I'm going to try really hard to copy and paste. Okay, I did a good job. Okay. So this this down here is the chain rule here, right? So altogether, what will we be doing? We'll have this left-hand side is equal to 0 plus this. Okay. So I think this warrants a new page. So let's add a page below. So let's see here. So we got e to the y cosine x y prime. This will make my life easier. So I'm just going to copy this. Copy. Paste. So I've got this is equal to 0 plus, we can go over here, copy, paste. Okay, good. So now our goal is to solve for y prime, right? So I'm going to essentially move this over here and move this over here so that I can have all of my y primes on one side. So I've got e to the y cosine x y prime minus x cosine xy y prime equals y cosine xy plus e to the y sine x. Now I'm going to factor out y prime. So I'll have y prime times some stuff equals y cosine xy plus e to the y sine x. And what is this factor in front of my y prime? It'll be e to the y cosine x, right? So that is going to go in there. And then minus this right here, x cosine xy. My last step is going to be to divide both sides by e to the y cosine x minus x cosine xy. E to the y cosine x minus x cosine xy. And I'm left with, I think I can use red here, y prime equals y cosine xy plus e to the y sine x divided by e to the y cosine x minus x cosine xy. Sorry about that. Here we go. And that's the solution for that one. All right, now let's do this one. So by now we should know the drill. We're going to take the derivative with respect to x of the left-hand side, which is tangent of x minus y. And that's going to be equal to the derivative with respect to x of the right-hand side, which is y over 1 plus x squared. Okay, so now how do we find the derivative, this derivative? We're going to have to use the chain rule. So let's go ahead and jump right in. So I'm going to leave a little space for myself. So if I want the derivative with respect to x of tangent x minus y, now why is it, how do I know that I need to do the How do I know that I need to do the chain rule? Because I've got a composition of functions. So my x's and y's are combined in a way where you've got an inner and an outer, okay? This is not going to be product rule because nothing is being multiplied. You don't have the product of two functions. It's going to be a chain rule, and now here's how we get it started. What is my outer function? Outer function is just going to be tan of x. What is my inner function? Inner function is going to be x minus y. Okay? So, f of x is going to be tan x, and g of x is going to be x minus y. The next thing I need is f prime of x. So what's the derivative of tangent of x? What's the derivative of tangent of x? Secant squared x. And what is the derivative of x minus y? It's going to be 1 minus y prime. Okay. So, my ddx of the tangent of x minus y is going to be f prime of g of x times g prime of x. Okay. My f prime is secant squared x, so I'll have secant squared g of x. And then my g prime is 1 minus y prime. Now what is g of x? G of x is x minus y. So I'll have secant squared of x minus y times 1 minus y prime. Okay. And I can rewrite this actually as, so I'm going to expand it. So I have secant squared x minus y minus secant squared x minus y times y prime. Copy, paste. Right, so that is that derivative. In order to do it, I use the chain rule. Now, let's find our derivative of the right-hand side of the equation. Now, how are we going to do this? Oh boy. Oh boy. I think we'll do quotient rule. Why? Because I'm dividing two functions. So now, my quotient rule, I believe, and I'm always getting this confused, but I think the quotient rule is f over g prime equals f prime g minus fg prime over g squared. I think that is the quotient rule. I derived it on the last one. But I just want to verify quotient rule is what is the quotient rule? Quotient rule is, see, I'm getting it confused. No, this is it. This is it. Derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. Okay. All right. So let's go ahead and try to find or compute, not find it, it's not lost. We want to compute the derivative with respect to x of, what do we have here? Y over 1 plus x squared. Y over 1 plus x squared. Okay, so now my top is, is y. My bottom is 1 plus x squared. Okay, so I'm just going to call this my f of x, and this my g of x. And I need f prime. That's just going to be y prime. And I also need g prime. That's going to be 2x. So, for my formula, let's see if I've got it correct. d dx of y divided by 1 plus x squared is equal to, and I need f prime g minus f g prime over g squared, right? F prime we said is y prime. Y prime. G, what's g? G is 1 plus x squared. Minus f, which is just y. G prime, which is 2x. And all of this divided by g squared. And g squared is 1 plus x squared. Quantity squared. Okay? So what will I get? I will get 1 plus x squared y prime minus 2xy. But I'm actually going to simplify this to be y prime over 1 plus x squared divided by 2xy over 1 plus x squared, quantity squared, right? So I can write this as 1 over 1 plus x squared times y prime minus 2xy over 1 plus x squared, quantity squared. And keep in mind, I'm always, in the back of my mind, recognizing that I'm going to need to get y prime by itself. So when I'm doing these problems, I just go ahead and, I go ahead and simplify wherever I can so that it's easier for me later on. So copy, paste. All right. So now we'll have the left-hand side equals the right-hand side. So that's actually not that bad. Let's go ahead and, need to add a page below. Paste. So this is the right-hand side. And I have that equal to, and my left-hand side is going to be all of this. So if we copy, paste, good. Okay, so now I need to solve for y prime. So I'm going to move that over there, move this over here, so that I can have my y primes together. So I'll have, actually, it makes more sense because I don't like to deal with negatives. I'm going to move this over here and move this over here. Okay, let's go. Okay, so I'll have 1 over 1 plus x squared, y prime, plus secant squared x minus y, y prime. All of that is equal to secant squared x minus y plus 2xy divided by quantity 1 plus x squared squared. So I'm going to factor out a y prime on the right-hand side, and that's going to equal secant squared x minus y plus 2xy over 1 plus x squared, quantity squared. And this factor for the right-hand side is going to be 1 over 1 plus x squared plus secant squared x minus y. Now I'm going to divide both sides by that factor, right? So I get y prime equals, oh boy, this is going to be not cute. Secant squared x minus y plus 2xy over 1 plus x squared, quantity squared, divided by secant squared x minus y plus 1 over 1 plus x squared. Excuse me. And now, the fastest way to simplify it, I know, is to multiply the top and the bottom by 1 plus x squared. Okay, and then multiply the top and the bottom by 1 plus x squared. Oh, this would be better. I'll just multiply the top and the bottom by 1 plus x squared, quantity squared. Okay, because if I multiply by 1 plus x squared, quantity squared, the top and the bottom, x squared, quantity squared, this is going to, so I'll have to distribute it out, right? So I'll have one plus x squared, quantity squared, secant squared, quantity x minus y, plus 2xy divided by, and in the denominator, I'll have 1 plus x squared, quantity squared, secant squared x minus y, plus 1 plus x squared. Okay, and all of this is equal to my y prime. Okie dokie. Now we are ready for question B. Okay, so B says if f of x plus x squared plus times f cubed is equal to 10 and f of 1 is equal to 2, find f prime of 1. Okay, this is truly about implicit differentiation. So we can rewrite this equation here. So we've got this equation. This is the first piece of information we're given, is that we've got this equation. So we can rewrite that equation as follows. Y plus x squared y cubed equals 10, right? Now, to find f prime is essentially finding dy dx. So we're going to take the derivative with respect to x of the left-hand side, set it equal to the derivative with respect to x of the right-hand side. So it's y plus x squared y cubed. Okay, so we'll get derivative with respect to x of y plus the derivative with respect to x of x squared y cubed equals derivative with respect to x of 10. Okay. Now, the derivative of 10 is just going to be equal to 0. Okay. The derivative of y with respect to x is just going to be equal to y prime. However, to find the derivative of x squared y cubed with respect to x, we need to use the product rule. Okay. So let's kind of jump down here. So if I want d dx of x squared y cubed, that's going to be d dx of x squared times y cubed plus x squared times d dx y cubed. Okay. Now, what is the derivative of x squared with respect to x? 2x. Y cubed is just going to stay the same. Okay. Now, x squared, that just stays the same. But now I need the derivative of y cubed. And to do the derivative of y cubed, honestly, I need the chain rule. Now, it could be that you can do it in your head, but let me show you how to do it using how the chain rule gives you that derivative. Okay, so we've got d dx, this is what we want, of y cubed, right? equals what? So our outer is x cubed. Inner, y. So this is f of x. This is g of x. Okay. F prime of x, 3x squared. G prime of x, y prime. So this derivative that we're searching, that we're trying to compute, of y cubed, is going to be f prime of g of x times g prime of x. Okay. What is f prime? 3x squared. So f prime of g of x is going to be 3g of x squared. And g prime we said is y prime, so we'll have y prime. But what is g of x? G of x is simply y. So we'll have 3y squared y prime. So let's put that in here. 3y squared y prime. Okay? So our derivative is equal to 2x times y cubed plus x squared times 3y squared y prime. So we get 2xy cubed plus 3x squared y prime. And we can put this right up here. Okay. So, let's see here. So, the equation that we have at this point is that y prime plus 2xy cubed plus 3x squared y prime equals 0. Copy. Okay. And now, so this is the equation so far. And now we can find a formula for y prime that's more explicit. So we can gather all of our y primes together. So we'll have y prime plus 3x squared y prime equals negative 2xy cubed. Factor out y prime. 1 plus 3x squared y squared times y prime equals negative 2xy cubed. So now we get y prime equals negative 2xy cubed divided by 1 plus 3x squared y squared. Our original question was asking us to find f prime of 1, okay? And they told us that f of 1 is equal to 2. So we need to find, let's see here, so we can put everything back in terms of f prime, right? So f prime of x is equal to negative 2x f of x cubed over 1 plus 3x squared f of x squared. And we know that f of 1 equals, what is it, 2? Equals 2, and our goal is to find f prime of 1. We just plug it into here. F prime of 1 equals, copy, paste. Okay, so now everywhere that I see an x, I'm going to replace it with a 1. So that's a 1. This x, I'm going to replace it with a 1. This x squared, I'm going to replace it with a 1. And this x, I'm going to replace it with a 1. Okay. So, this is going to be equal to, so we know that f of 1 is equal to 2. So I can go back and replace f of 1 with 2. F of 1 replaced with 2. So my final answer is going to be negative 2 times 8 divided by 1 plus 3 times 4. So it'll be negative 16 over 13. So that is the final answer. F prime of 1 is equal to negative 16 over 13. Okay. And now we have the last problem here, which is going to involve implicit differentiation. So the key fact that we need to know is that the formula that we need to use is that the equation of our line is going to be given by, so this is equation of tangent line here's the general format, y equals f of a plus f prime of a times x minus a. Okay, so we need to figure out what is a, what is f of a, and what is f prime of a. Okay, right here we are given, so we are given the information. This point gives us a and f of a. So a is going to be 1, and f of a is also going to be 1. So we can go here and say already that we know that a is equal to 1 and f of a is equal to 1. We can plug it, in fact, into our formula here. So f of a is 1, a is 1. So now what we need to find is essentially f prime of 1. Now we move to this implicitly defined equation. So we need to find y prime or f prime of 1. So we have here f, so we can rewrite it first as x squared plus x f of x. Well, no, actually I like it to be left as it is with the y. So we'll have here f x squared plus xy plus y squared equals 3. So we're going to take the derivative with respect to x of x squared plus the derivative with respect to x of xy plus the derivative with respect to x of y squared is equal to the derivative with respect to x of 3. Now, this derivative of 3 is just going to be equal to 0 because 3 is a constant. The derivative of x squared is just going to be 2x. The derivative of xy, we need to use the product rule. And for the derivative of y squared, we're essentially going to use the chain rule. Okay. So now what is our d dx of xy is going to be d dx of x times y plus x times d dx of y. d dx of x, that's just 1. Y doesn't change, so that's just y. X doesn't change, and dy dx is just going to be y prime. So when we put it all together, we're going to get 1 times y plus x times y prime. Y plus x y prime. So let's put that here. Y plus x y prime. And now, to figure out the derivative with respect to x of y squared, we say our outer function is going to be x squared. Our inner function is going to be y. We need the derivative of the outer function. That's going to be 2x. And the derivative of the inner function, that's going to be y prime. And so now, our derivative of y squared is going to be f prime of g of x times g prime of x. F prime is 2x, so we'll have 2 times g of x. G prime is y prime times y prime. But g of x is really equal to y. Do you see? G of x is equal to y. So we'll have 2y prime. So up here, we'll put 2y prime. So our equation becomes 2x plus y plus xy prime plus 2y prime equals 0. Okay. So now, let's see here, maybe we can, let's try to, so this was a little portion to figure this out. This was a little bit of math we did to figure out this derivative. Okay, so now our official equation is going to be 2xy. This isn't the equation of the tangent line. This is the equation of the curve, right? So we have the equation of the curve, and we took the derivative with respect to x, and this is the result. And our goal is to find f prime of 1. Okay, so we'll combine like terms. Okay, this is equal to negative 2x minus y. So y prime is equal to negative 2x minus y divided by x plus 2y. Okay, and now if we rewrite this, let me add 1. Let's see here, maybe I can just copy, paste. Okay, so this is what we're working with. So now I'm just going to rewrite it in terms of f prime of x is equal to negative 2x minus f of x, right? Because y equals f of x, and y prime is the same as f prime of x, okay? Divided by, in terms of our notation, x plus 2f of x. So f prime of 1 is going to be negative 2 times 1 minus f of 1 divided by 1 plus 2 f of 1. Okay? Now, what is f of 1? F of 1 is equal to 1, right? Because a is equal to 1. So does everybody see that? This is where we're looking here. So f of 1 is equal to 1. So we'll have, this is equal to negative 2 minus 1 divided by 1 plus 2 times 1. So that'll be negative 3 over 3, negative 1. Ah, okay. So our final answer is going to be y equals f of a. Didn't we say f of a plus f prime of a, x minus a? And a equals 1. F prime of a equals 1. And we just found that f double prime, f of a equals 1, and f prime of a is going to equal negative 1. Okay, so then our final answer, we're switching to red here, is y equals 1 minus x minus 1. There we go. Thank you. I hope this has been helpful.